So we're going to be doing intermediate data visualization in R this week. So just a workshop overview. We're going to be building off the fundamentals from the intro data visualization in R, just kind of getting into more advanced aesthetics within ggplot. That's the package we're still going to work with, as well as learn some stuff about like faceting and looking at multivariate relationships and scatter plots. And as well as just kind of putting all that stuff together and doing some practice. So it's not going to be a lot of new stuff here. It's just going to be a lot of stuff you already know, but just kind of with some minor details to make your graphs a little bit better. I just wanted to also just go over like if you haven't discovered the Carbon course much, there's a resources tab on the BDA Data Mastery page where, if you want to go a little bit deeper into the things we're talking about in these workshops, you can go here to this R learning resources or the Python learning resources, and you can go ahead here, and I've put like a lot of these different resources here for you to keep going. Like for example, today with data visualization, there's this data visualization with R book. It's another resource where you can, extend your knowledge a bit more from what we've learned. This covers a lot more than what I'm covering in this one. So if you want more, detailed look into visualizations, this is a resource you can use. So I just wanted to put that out there in case anyone wasn't aware. But with that, we're just going to go ahead and get right into the notebook. So I'm going to send the link to the workspace if you guys haven't joined, but I'm sure most of you have. But just go ahead and click that link. And we're going to be using a built-in dataset in R, so you don't have to download anything to your local file. So just same thing as always, click that link, and it's going to ask you to log in with your email. I've already logged in myself. And you're going to get to this space here. So I've created an assignment, which is the intermediate data visualization in R, and it says start. So go ahead and click that, and it's going to load up the project. So let me know if you guys have that. I'm sure it won't take much time, but it's just going to load, and then we'll get started. So just go down here and go to files, and there's this intermediate data visualization R markdown file that we want to pull up. That's the file we're going to be working with. So just click on that. It's going to pull the console here to the left. I always like to do this, and you can do this if you want to as well, just because it's easier to visualize stuff. But you can go to your tools and your global options. And if you go to pane layout, I like to move my console up in the top right here so I can like see how things render as I go along in the source code right there. So just go here and just change this to console and click apply. And once you do that, you have your console on the right side and your source code here on the left. So I just, makes it easy to work with. So we're going to first load in the packages that we are going to need. So we're going to need to install one package, which is called Tidyverse. That's what we've been working in all this time. So to do that, we're going to do install .packages and then Tidyverse. And again, this red stop sign just means that there's a process going on, so it'll take a few minutes. And just as a reminder, the reason why I'm loading Tidyverse and not specifically ggplot is because Tidyverse is the kind of like the umbrella package, which has all these other meta packages inside there. So Tidyverse hosts like ggplot and dplyr, and so those already come installed once you install this package. So as we can see here, it's been downloaded. So we're going to load in with the library function. So to do that, we just call library and pass in the package name. And so Datasets is one we're going to load in first. This one's already installed into R by default, so we don't need to manually install .package. So go ahead and do library and then Datasets. and then dplyr and ggplot2. And then ggplot2. And so now when you run this, our packages are now loaded into our environment, so we can go ahead and get started. So like I said, the dataset that we're going to be working with is already installed in the datasets package. So the name of that dataset is called empty cars. So to do that, let's retrieve the head of the empty cars data. So let's do head empty cars, right? And if you do this, it might not seem as obvious as to what this data set is. Since this data set is built into the R ecosystem, we can actually take a look at what this data set is. So to do so, you can run the command question mark. So question mark, actually I could even do it in the console. If you do question mark empty cars, you can do this when you look up any function, just question mark the thing and the object. And so if you run that, it pulls up the empty cars data set and some information on it. So we can see that it's called Motor Trend Car Road Test. So it was extracted from the Motor Trend US magazine and comprises of fuel consumption and various features of automobile design. So here it gives us, the various column names, and we can, see how many observations and the numeric variables, things like that. And so I just want to kind of go over some of the column names if they didn't make sense. So, we see the miles per gallon, the cylinders, the horsepower, quarter seconds or 1/4 mile time, what type of engine it is, V-shaped or straight, transmission, and things like that. So this is all good, but let's kind of do some initial data wrangling just so we can kind of work with these columns a little bit better. Some of these columns are not as interpretable, like, VS means engine, right? I think it would be good if we could rename some of these columns so then when we use them later on, they make more sense in our plots. So let's go ahead and let's just kind of review some basic data manipulation first. So let's rename the axle ratio, the DRAT column to axle ratio, weight, and let's just call it weight. Rename the engine, transmission, carburetors to carb to carburetors, and then set that renamed empty cars object to a new object called df. So we're going to be just transforming our data here. So call it df and set it equal, and then we're going to call empty cars, which is our original data set, and we're going to rename the following columns. So remember, when you rename, you put your new column name on the left and set it equal to the old column name on the right. So we're going to call it axle ratio, and that's the original DRAT column, and then we're going to rename weight, and then engine is VS, carburetors is what I'm going to call it, carb, and then that's it. So we're going to rename those 5 columns or 4 columns here. Did I get axle ratio, weight, engine, transmission, I forgot that one. So transmission, and we're going to rename the original AM column. And then let's just check the head of the data frame that it returned just to see that our changes are still intact. So if we do that now, we see that our columns are transformed. So you see that weight, engine, transmission, our columns are now more interpretable. So now we're going to be working with this new data frame object that we created. So let's now see how we can transform this a bit more. So as you can see here, when we glimpse this data frame, right?
Could you please go up? Because I did get all the...
Oh, yeah. Yeah, so just rename the axle ratio, the DRAT, weight, transmission, engine, and carburetors. So yeah, so as you can see here, we have all these columns, but it would be kind of nice if we could have these individual observations and these individual models as its individual column, right? Right now, there's no column name above it. It's specifically the index of the data frame, but it would be a lot nicer if we had a column specifically called models, where we had all these model names, right? So to do that, what we're going to do is we're going to create a new column in our data frame, and we're just going to, and to do that, you take the data frame object and you specify the new column name. So, let's say we call it data frame models, right? The $sign is like how you index into that data frame, and then you set it equal to the values that you want it to be. So the way you can get these values, right, is with this row names function. So if we do row names df, we have all the different models that we want as our observations in the column section, right? So all we need to do is create a model column and then set it equal to the row names of the data frame, right? So let's go ahead and do that. So let's call it models. So let's do df models, and let's set it equal to the various observations that we want. So row names df, right? And then let's glimpse this now, this new data frame, to see if this took place. So you can see here now we have this added column here called models, and we have all the different automobiles, right? So now that our data is like transformed, we have the correct columns we want to use. Let's go and do some data visualization now. So a lot of the stuff that I'm going to teach you today is actually just kind of better ways of visualizing your data and like deeper, more more insightful relationships that you can find. The same thing always goes for data visualization in R and ggplot in general. You take your data frame, you pass it in. It's a kind of like layers. You plot your graphs as layers, right? You have your first layer, which is your data. Then your second layer is the aesthetic mappings, like your X and Y, what you want to fill by, like the various variables from your data set. And then the third layer is that specific geometry that you want your plot to be, whether it's going to be a point with a scatter plot, or if it's going to be a histogram, a bar plot. That's like the 3-layer mapping system of ggplot, and that's why we like to use it. So one other thing I'm going to show you is, the same code as before. We, plot it, have our X and Y's, we can fill it by a third categorical variable. But another thing I like to do is I like to facet the plot by another categorical variable, or the same one. And so that's what a facet grid does. So what a facet grid will do is kind of split your original graph up into 2 separate kind of subplots by another categorical variable. So to do that, you have the code, and then if I fill this, right, I like to wrap the variable that I'm filling by as a factor. And what a factor is in R is just a data type. It represents categorical variables in R. So like, like your discrete observations, so like 0, 1. So in this case, transmission 0, 1, that's a factor variable. But sometimes it's not labeled as it in the data set. So we wrap that variable in the factor function just so the graph like knows, or it will render it improperly. So the fill argument, and then you call facet underscore grid, and then you can pass in either rows or columns that you want to facet by. So hence the name grid, but you can also do either just columns or rows. So in this case, I'm going to facet by columns, and you wrap the variable that you want to facet by in the vars, or variables, right? So you just kind of add it as like a plus sign, and then facet grid the columns. And then what this scales free does is that if there's a plot which maybe has a different scale, so like if you're going to facet by a categorical variable, right, most likely the scales that it's going to be kind of like grouped by aren't going to be the same. So if you make your scales as free, it shares the same scales, right? And if you like sometimes don't include this argument, your graph won't render like neatly. So let's go ahead and like, try this. So let's plot a histogram of the miles per gallon, bin width of 5, and then fill it with the transmission categorical variable, make a facet grid with the transmission as the columns, and then make the scales free. So let's go ahead and do that. So let's do df, and then I'm going to use the pipe operator, and then ggplot AES to set your aesthetic mappings. Since it's a histogram, we only want our X, right? MPG, and then we're going to fill it by a factor variable, which is going to be transmission. And then now we're going to do our geometry mapping. So that's geom histogram. And then we are going to set the bin width, right, to 5. And then we're going to now facet grid. And we're going to facet the columns. So we're going to facet it by column. So we're going to do calls is equal to vars transmission. So now when you plot this, we can see, right, our distribution of the miles per gallon differs whether it's a V-shaped or straight engine, right? This is what this facet grid shows us. And that's really why I like to use it, because it kind of tells more about a distribution more than just one histogram. And obviously you can go through in your data set and relabel these so it shows V-shaped and straight, but that's how you would do it. So let's do some more. Let's plot a bar chart of the different models and their respective weights filled by the engine, make a facet grid with the engine as rows, and make the scales free. So let's kind of think about this here. So we're going to be putting the weights and making a bar chart with the different models. Now there's a lot of different models in this, and I don't think if it was on the x-axis, the plot would look very neat. So let's do a horizontal bar plot. Let's put the models on the y-axis, and let's put our weights on the x-axis. So let's do df ggplot AES, and let's do our x is equal to our weights. So weight, y is equal to models, and then let's fill it by a factor variable called engine. That's from our data. And then we're going to do geom col for our bar chart. And now we're going to facet grid with our, we're going to facet by rows this time. So we're going to specify rows, and then with the variable engine that we are filling by. And then we're going to make the scales free. So now if we run this, I'm just going to highlight this and then run selected lines. You can see here that we can see how the different models in our data set vary by the various engine types. And I'm sure you can see now why I like to make it on the y-axis, because if you put this on the x-axis, it would kind of be unreadable. So that's a facet bar chart. And now let's do one more. Let's plot a density plot of the distribution of weight filled by engine, and make a facet grid with the gear as rows and engine as columns. So we're going to be faceting by rows and columns and make the scales free. So df ggplot AES for aesthetics, and we're going to make a density plot. So this is kind of like a histogram, so we're just going to need an x variable, and then we're going to fill it by a factor variable called engine, and then density plot, so geom density, and then we're going to make a facet grid by rows and columns. So for rows, it's going to be the gear column, and then for calls or columns, it's going to be engine, so vars engine, and then we're going to make the scales free. So if I run this whole cell, we see all of our plots now. But now our final one, we can see that this is what facet grid does. It facets our density plot, our distribution of the weight via the transmission, via the gear and the engine. So you can see, it depends whether it's a like 3, 4, 5 gear, or what kind of engine it is, right? So our distribution is different for each, and we can see that from here. So that's kind of facet grids. It's something I use really very much often when I use R for data visualization or data science in general. Definitely a very good function to use when you're creating visualizations for this reason. So now we're gonna kind of go a bit deeper into scatter plots and like more advanced aesthetics. So in when we did scatter plots in intro to data visualization, I just kind of showed you how to make a scatter plot, but it's more, it'd be better if we can see like how strong the relationship is between those two numeric variables, and we can do so by plotting a regression line through that. So really, this isn't very much new to you guys. You know how to create a scatter plot in R. You set your data frame, your aesthetic mapping. Since it's a scatter plot, we want an X and Y variable for our relationship to show. Geom point is how you specify that you want a scatter plot. And then to add a regression line through your points, you specify a function called geom smooth. And you put two arguments in that. One is the method, so what kind of line you want, right? So in regression, there's many types of lines. You can have a linear model. So most likely, since we're mapping X and Y, if it's a linear relationship and we want to show that line, we do LM for linear model. And then SE is the standard error. So if you make that true, it's going to show your standard error bars, but we only want the line. So we're going to set that equal to false, right? And so again, you can adjust this method for like, depending on what kind of data you have, or if it's, there's LM for linear model, GLM for generalized linear model. It really depends on what data you have and what you want to show. So let's go ahead and practice. Let's plot a scatter plot of the relationship between weight and miles per gallon, and then plot a regression line. So let's do df ggplot AES x, or x is going to be our weight, and y is equal to miles per gallon. And then we're going to do a geom point for a scatter plot. And then let's add a regression line. So geom smooth. And we're going to do, the method is going to be LM for linear model, and SE is going to be false. So if we plot that, we see our scatter plot here. So you can see what kind of relationship weight and miles per gallon have. And so let's do another one. Let's do a scatter plot of the relationship between weight and horsepower. So let's do df ggplot AES x weight, y is horsepower, geom point, and then geom smooth to plot that linear model, and then SE is false, right? And now when we run that, we get, again, another relationship between weight and horsepower with that line to quantify how strong that relationship is. And then let's do one more. Let's plot a scatter plot of the relationship between weight and quarter seconds, and then same thing, plot a regression line. So df ggplot AES x is I say weight, y is q sec, geom point, method is equal to LM, and SE is false. So I'm just going to highlight this, run selected lines, and we can see another regression line, right? So, this is great. I'm going to be kind of showing the same plot with the same exact relationships through the next few exercises too, just to kind of show you how we can go a lot farther than just this, right? We started with just plotting our points. All right, that was a good first step. And now I showed you how to plot a regression line. But what if we want to kind of go a bit deeper into this? And we can do this with our advanced aesthetics. So, what I mean by aesthetics is we always make this AES function in our ggplot function when we pass it in, right? So AES stands for aesthetics, and that's our aesthetic mappings for our data. So that has a lot of different arguments. So like the ones we've been using so far are X, Y to tell what's going to be our X axis, what's going to be our Y axis. Fill is going to be what's the categorical variable we want to, fill the data by or categorize by. But there's also two other ones which are really useful and which I use for scatter plots a lot, and that's size and color. Right? So we can add more layers of aesthetics to show multivariate relationships, right? XY fill is three different, it's like a 3D relationship that I'm showing you. But with size and color, you can really add complexity to your graphs and, really explore more and deeper between these, the relationship between these variables in your data set. So I'm going to go over the size aesthetic. So the size aesthetic kind of helps us see how the various points on our scatter plot are weighted by some other numeric variable. So the way you implement this is you do the same thing, right? Your ggplot, your point, your geom smooth, but you just pass in another aesthetic variable, and that's called size. So size is the aesthetic argument that we're going to add on top of x and y, and that's going to be that numeric variable that we want to show the weight of, right? So you're going to see as we go through, I'm just kind of building off that original regression plots we did here, just to kind of see how complex we can make these plots. So let's plot a scatter plot between the weight in miles per gallon, set the aesthetic for the size to qsec at a quarter seconds, and add a smooth regression line. So let's do df ggplot AES. X is the weight, y is miles per gallon, size is a quarter seconds, plus the geom point, and then geom smooth to add our regression line. So it's going to be LM, and then SE is false, right? So I just kind of show you, originally we had like our original plot was just this, right? Weight in miles per gallon, our points were like this. But now if we add this, we can see the size of our points vary by this, our third different relationship here, our size aesthetic, right? So we can see, and there's a legend here that shows us the kind of like the scale is how the various data points, what like kind of weights the most by this qsec variable, and that's what the size aesthetic does essentially, and it's very helpful when you want to see how your data points vary amongst a numeric variable. So let's do a few more. Let's do for weight in HP, and by weight in horsepower, and set the size aesthetic to miles per gallon. So let's do ggplot AES, x is equal to weight, y is horsepower, and size is equal to miles per gallon, and then geom point, and then geom smooth method is LM, and SE false. Okay, and if we run this, okay, I don't know why that's happening. Selected lines. All right, there's some error help. I'm just gonna have to refresh this, I guess. Yeah, this was happening when I was creating this as well. Okay, looks like we're good. So I'm just gonna rerun it. So we can see here now our weight and horsepower, how it varies by miles per gallon. We can see, a big cluster of them right here. Around the 30 miles per gallon range, and then we can see how it varies as the weight increases and horsepower increases. You can see it gets smaller, right? So that's another relationship that we saw amongst the third variable in our data set. So let's do one more. Let's do df ggplot AES, and then let's do weight and qsec. I should probably change this. qsec, and we're going to set the size aesthetic to horsepower this time. And we're going to do the same thing, geom point and geom smooth for our regression line. And let's run this. Hopefully this runs properly. And you can see here, we get that size aesthetic taking hold. So that's the size aesthetic, and I really like it because it reveals a lot of interesting patterns and how they vary across two other numerical variables. So that's size. And then another one I want to talk about is the color aesthetic, right? So what if we wanted to kind of see how our data points on our scatter plot varied by a categorical variable, right? We did it by a numerical variable. Now let's see how we can separate those points into various categories and if we can cluster it in any sort of way, right? So we can do this with the color aesthetic. And what that is, it just basically colors your points by the 2 categories or however many categories you have. So to do that, it's same setup as before, except you just, you can pass in the color aesthetic argument into your AES function and specify a categorical variable. And just for best practices, I like to wrap it in factor because then that just guarantees, ggplot just guarantees that it's going to be by a categorical variable. And then geom point and geom smooth, right? So let's plot a scatter plot between weight and miles per gallon, same thing. And we're gonna, in this time, just show it by color. So df ggplot AES, x equals weight, y is miles per gallon, and then this time color, and we're gonna do it by the engine factor categorical variable, and then we're going to do geom point, geom smooth, method is lm, and don't show the standard error bars, right? So the reason why I like this one too is because not only does it just kind of separate the points by the various categories, but if you put geom smooth, it also plots 2 different regression lines. So you can see how the lines vary by the various different categories, right? So this is a lot deeper insights from your scatter plot. So we can see, the relationship between weight and miles per gallon varies if it's V-shaped versus straight engine, right? So now let's keep going. Let's do it for the weight and horsepower, and let's color the points by transmission. So df ggplot AES weight on the x, y is horsepower, and then for color, let's do a factor variable called transmission, and then geom point, geom smooth, method is lm, and SE is false, right? And then let's run that. Same thing. You can see that, the slope of your regression line is going to vary by transmission. And we can see that by this color argument here in our aesthetics, right? Now let's do one more. Let's plot scatter plot between weights and QSEC and color the points by gear. So let's do df ggplot AES, x is weight, y is QSEC, and color is gear. So factor gear, geom point, and then geom smooth is method lm for linear model, and SE is false. So now let's run the whole cell. And we can see here now that we have 3 different gears, so it depends on if it's a 3, 4, or 5 gear. We can see that the weight versus the 1/4 mile time or QSEC varies. And we can see that the slopes drastically change by the type of gear it is. So that's the color aesthetic. And I really like that because especially when you're kind of comparing 3 different like observations or categories, or if you want to see, there's a type of modeling called linear mixed modeling. It's used to kind of look at your randomness above with like subjects. These, this geom smooth and this color aesthetic is really good for kind of visualizing those different regression lines depending on your observations. So that's your color aesthetic. So let's now put it all together and let's use the color aesthetic and our size aesthetic together. And let's plot a scatter plot, the ones we did before, so I can show you how together they make our plots even better. So let's do ggplot df ggplot AES, x is weight, y is miles per gallon, our size is QSEC, and then and then we're going to do color is going to be engine. So we're going to specify the two aesthetics, right? So size and color this time. Geom point, geom smooth, method is linear model, and then y is, or SE, don't show the error bars. So we can see now how together it makes our plots even better. So same thing, it shows those two different lines, and then we can see how it varies by the 1/4 mile time. And our plot got way better than just a basic scatter plot, right? So let's do the same thing for the other two. Weight and horsepower, the size aesthetic is going to be miles per gallon, and the color aesthetic is going to be transmission. So DF, ggplot, AES, X is weight, Y is horsepower, size is miles per gallon, and the color is going to be our transmission, right? And geom point and geom smooth, and as our linear model, and false. So let's run this and let's see what we get. So we can see again our relationship between the size and color aesthetic and what it shows us here, right? Now let's do another one. Let's do scatter plot between weight and quarter seconds, map the size aesthetic to horsepower and the color aesthetic to gear. So do ggplot, AES, X is weight, Y is QSEC, and then the size will be horsepower, and then our color will be by the factor variable gear. And then geom point, and then geom smooth method LM SE is false. So let's run that, and we can see again how our plot just got even better with that size and color aesthetic together. So I hope I convinced you that ggplot has a really good arguments in that aesthetic function. You can really extract and mine your data a lot better when you incorporate these aesthetic arguments in your plots and your scatter plots. And just some additional customizations. You know, if you wanted to, let's say, like make your this is for like aesthetically pleasing things, but like if your bar graph or histograms, you know, you wanted to kind of dodge the position or make them like kind of side by side, you could just pass in this position argument for your histogram or a bar plot and just specify position equals to dodge. So that does that. I do that sometimes when my histogram isn't kind of showing up properly, or if I'm faceting and I wanted to make sure my columns are next to each other and neat, I like to pass in this position dodge argument. Similarly, sometimes if you plot scatter plots, your points will kind of just have one single, like it'll look like all your points are in one position. If you wanted to kind of add some noise or randomness to the points on how they appear, you can pass in this position and then jitter, which kind of just like adds randomness to your points on your scatter plot. Just some kind of small things to make your plots look better. And I haven't been doing so far, but of course, make sure you always label your title. It already labels your axis labels for you, but make sure you add a good title to your plots, or they're meaningless. So let's do some more practice. So now we're just kind of like put this all together. So I showed you a lot with scatter plots. I'm going to show you one more scatter plot, a histogram, and a bar chart, and we're just kind of we're going to put together all of our aesthetics, the faceting, and see what we can kind of show here. So let's plot a scatter plot of the relationship with miles per gallon and weight. So DF, ggplot, AES, X is miles per gallon, Y is weight, and then our color aesthetic to engine, so factor engine, and our size aesthetic to QSEC, so QSEC, and then I'm going to jitter the position of the points. So position jitter. By the way, if you're typing this out, you don't have to kind of like write it all in a row. If you just add a plus sign and do a new line, ggplot knows that you're going to continue, but make sure you always have that plus sign so it knows that it's going to continue on to the next line. And then we're going to plot a smooth regression line. So geom smooth, method is lm, se is false, and then we're going to facet this by columns, and we're going to facet by the gear column. So facet grid calls the variable called gear, and we're going to make our scales free so they show up better. So now when we plot this, we can see now that we can break up the data points of our scatter plot and see how it varies by the different engines and all the kind of size and color aesthetics that we have looked at. So this is nice. It like groups it by the various faceting grids, like the column we specified here for gear, and then also by another factor. So this is what I'm talking about when I say multivariate relationships here. We got like 1, 2, 3, 4, 5 different relationships I'm trying to show you on one plot. So this is great here. And so we can do the same with other plots too, right? So it's not just scatter plots. Let's do plot a histogram of the distribution of weights, and this time we're going to set the fill aesthetic to gear. So we're bringing back the fill argument. Set the bin width to 0.5. I should probably pass the data frame in. ggplot AES x is so histogram. So it's going to be just the x argument, right? And then fill by the factor of gear. And then the geometry here is going to be a histogram. And then I want the bin width. I want to customize that to 0.5. If you're wondering why 0.5, it just takes experimentation. So like if you plot it originally and it doesn't look well, you can just kind of tweak it to what you want. And then let's also another argument we want to specify is the position. So I'm going to make it dodge here. And then I'm going to also make a facet grid. So facet grid by columns. So in this case, I'm going to facet where the columns are transmission and rows are engines. So calls is factor transmission. And then rows are engine here. And then set your scales to be free. Right. Transmission. Oh, whoops. I forgot to, okay. It was just out of habit. I said factor. Make sure this says vars, right? When you make your facet grid, make sure you wrap your variables in that vars or variables argument function. So now we can see here how our distribution varies, by our engine and our transmission, right, on the left and right here, and how it also varies by the type of gear, and how the weight varies amongst all of that. So really good. We can apply the aesthetics and all these faceting features to histograms as well. So we're going to do one more. We're going to do it for bar charts. So we're going to plot a bar chart of the engine and their corresponding weights, and then set the fill aesthetic to transmission. So here I'm going to plot the engine on the x-axis because I want that as my category, and then how the weights correspond to that. So what I'm going to do here is my AES, right? My X is going to be my engine, right? And I'm going to show you what happens when I don't wrap my engine in a factor function. So if I do engine, right, just engine, and then Y is equal to weight, and then my fill aesthetic, if I make that transmission. And then I'm going to now do geom_col for my geometry. And I'm going to set the position here to dodge. So I want to kind of dodge them. And then I'm going to create a facet grid. And where my rows here are going to be by the gear variable. So vars gear. And then going to set my scales to be free. So I'm going to show you what happens here when I don't wrap this engine in a factor function, and why I think, I've been saying this whole time why it's a best practice. So, we get our plot here, we see, okay, we see our bar plot changes by the various gears 3, 4, 5, and then also by transmission, right? 0 and 1 being the labels of the transmission. But this scale here is a bit deceptive, right? Our engine is only taking up 2 different observations. It's either V-shaped or straight. There's no -0.5 engine or 0.5 engine, right? From the plot, it shows 0 and 1, but our scales doesn't make sense. So that's why, if you're ever going to make a bar plot, or if you're going to use a categorical variable in your aesthetics, always make sure to wrap that in this factor function, because that will guarantee that you are plotting by a categorical variable. And it all comes down to the data set. Sometimes you'll get lucky and your categorical variables will be labeled as factors, but sometimes you don't, and they're just integers. And we want to make sure we handle that. So always just make sure wrap it in factor. You can always relabel this axis so it doesn't say factor engine. So yeah, so that's our bar chart faceted, and that is the end of today's workshop. So I'm glad you guys could come to the tonight's workshop in intermediate data visualization in R. Like I said, there's a lot of resources out there, especially that data visualization with R book. There's a lot deeper you can go with this. You can add themes, you can explore other aesthetic variables, but this is a really good start to how you can visualize your data in R. And I really urge you to go look at those resources on the Canvas page. This is going to be the last data visualization in our workshop for the semester. Our advanced data visualization series is going to be our data dashboarding series. So that's going to take place next semester. You're going to learn all about how to kind of take these plots that we do in our notebooks, because we can definitely put this on a bigger scale, and this is only scratching the surface, and how you can kind of put these plots on a dashboard that people can see and kind of adjust. So with that, you're going to learn R, Shiny, Streamlit, and Python. So I'm really excited for what we're going to bring for the advanced data dashboarding series and the advanced data visualization series next semester. So make sure you guys practice this stuff on your own data sets. I know some of you might be on BDART. Definitely use these videos as resources. And again, if you have any questions, feel free to Slack me or anything like that. But otherwise, have a good rest of your night. Thanks for coming.